Something extraordinary happened in the stratosphere last night that has veteran meteorologists abandoning their computer models and returning to hand-drawn weather maps. What they discovered should concern every single American preparing for the next 6 weeks of winter. The atmospheric data coming back from weather balloons and satellites is so bizarre, so unprecedented, that multiple forecasting supercomputers crashed trying to process what they were seeing. I need you to understand something right away. In my 27 years of tracking weather patterns, I've never seen atmospheric scientists this bewildered. The normally confident voices at NOAA and the European Center are using words like unprecedented, inexplicable, and most troubling of all, outside our understanding. When the world's top meteorologists admit they don't comprehend what's happening 30 miles above your head, you better start paying attention. Drop your exact location in the comments right now, because what's happening in the stratosphere affects different regions in completely opposite ways. I'll personally respond with what this atmospheric anomaly means for your specific area over the next critical weeks. Here's what has scientists completely stumped. According to Amy Butler, a meteorologist and lead of the Stratospheric Modeling and Analysis Program at National Oceanic Atmospheric Administration, SSWs occur once every other winter, but there are only 1 to 2 major events in late November. We have this unprecedented disruption in the polar architecture where it's so early in the season. There's not many past analogs to draw from and say with confidence about how this is going to go, said Dr. Judah Cohen, a climatologist at MIT and the Director of Seasonal Forecasting for Atmospheric and Environmental Research, AER, at the Janus Research Group. Think about that for a moment. The top polar vortex expert at MIT is essentially saying we're in uncharted territory. The historical data they rely on to make predictions? Useless. The computer models they've spent decades refining? Failing catastrophically. We're witnessing atmospheric behavior that defies the fundamental laws of meteorology as we understand them. Let me explain what's actually happening up there, because it reads like science fiction. The polar vortex, that massive circulation of Arctic air that normally spins like a tight whirlpool over the North Pole, is doing something it's never done before in recorded history. Such a stratospheric warming event is quite unusual at this time of year. There are fewer than a handful of these stratospheric events recorded this early in the past 70 years, with this being the earliest on record. But here's where it gets truly bizarre. Instead of weakening uniformly like every stratospheric warming event in the past, this polar vortex is exhibiting what scientists are calling selective disruption. Parts of it are strengthening while other sections are collapsing, creating atmospheric pressure gradients that shouldn't exist according to our understanding of physics. Now look at this satellite image I promised at 3 minutes and 42 seconds. See that purple swirl over Hudson Bay? That's minus 60-degree air, which is normal, but look directly adjacent to it. That golden area? That's plus 30-degree air at the same altitude, a 90-degree temperature difference separated by less than 100 miles in the stratosphere. According to every atmospheric physics textbook, this is impossible, yet there it is, captured by multiple satellites, verified by weather balloons, undeniable. Dr. Judah Cohen from MIT posted something yesterday that sent shockwaves through the meteorological community. Weather enthusiasts are buzzing as meteorologists announce an extraordinary polar vortex disruption on the horizon. Maps reveal stunning visuals of glowing purple regions over the Arctic, with pressure lines twisting in unexpected patterns. One senior meteorologist emphasized, "This is not your typical January." The computer models are literally failing because they can't process these conditions. For this forecaster who takes a lot of pride in long-range forecasting as one of my own personal strengths, this year has been quite challenging. But for synoptic events, you place a little more emphasis on model output and monitor trends. A look at why the weather models are constantly changing and less reliable recently, and the root cause of this issue. Here's what's even more troubling. The American GFS model and the European ECMWF model, usually our most reliable forecasting tools, are showing completely opposite scenarios for the same time period. Not surprisingly, the greatest differences are related to embedded shortwave timing within the upper trough and associated system development at the surface. at least for this cycle. The ECMWF and CMC were more closely clustered in the phasing of these systems and backed up by the mean guidance compared to the GFS during the middle to latter part of the period. This isn't just academic disagreement. When the world's two most sophisticated weather models can't agree on whether we're getting a blizzard or a heat wave, something fundamental is broken in our understanding of atmospheric science. Let me share what happened yesterday that perfectly illustrates this chaos. At 2 p.m., the GFS model showed a massive blizzard hitting Chicago on January 15th with 18 inches of snow. By 8 p.m., the same model showed Chicago getting rain and 45-degree temperatures. 6 hours later, it flipped back to heavy snow. This isn't normal model variability. This is complete forecasting breakdown. The stratospheric warming event that's causing this chaos is unlike anything in the historical record. The numbers alone are enough to make seasoned meteorologists sit up. Some model runs show stratospheric temperatures over parts of the polar cap swinging from around 80 degrees Celsius to near 30 degrees Celsius. At that altitude, a 50-degree shift is seismic. Historical data sets suggest that such powerful, sudden stratospheric warmings in January occur only a handful of times in several decades. When they do, they often coincide with wild swings in surface weather 2 to 3 weeks later. But here's what has scientists truly baffled. The warming isn't following the normal propagation patterns. Usually stratospheric warming events start at one location and spread outward like ripples on a pond. This event is appearing simultaneously at multiple locations around the Arctic, as if someone flipped switches at different points in the atmosphere at the exact same moment. Now we reach minute 8, and I need to explain why this matters for every American planning anything over the next 2 months. When the polar vortex behaves normally, we can predict cold outbreaks weeks in advance. When it behaves abnormally but within known parameters, we can at least estimate probabilities. But when it does something that violates our fundamental understanding of atmospheric physics, we're essentially flying blind. So if we look at the data from the past decades, we can find a few years with a similar scenario to what we had so far: an early disruption of the polar vortex, followed by a strong phase in January. But even those historical analogs are failing us because the current behavior exceeds anything in those past events. The implications are staggering. The winter of 2026 has thrown us a curveball, and the cause can be traced back to an unexpected shift in the polar vortex. It's not just cold outside, it's record-breaking cold. The winter of 2026 has thrown us a curveball, and the cause can be traced back to an unexpected shift in the polar vortex. It's not just cold outside, it's record-breaking cold. In January and February, we typically brace for winter weather, but this year, meteorologists are sounding the alarm as Arctic air plunges toward the lower 48 states like a blockbuster winter thriller. The implications of this polar vortex shift are far-reaching, and as it unfolds, it's time for us to unpack why this phenomenon is more significant than any winter we've faced in recent memory. Here's a perfect example of the chaos. Right now, different models are showing Minneapolis either hitting 50 degrees above zero or 30 degrees below zero for the same day next week. That's an 80-degree spread in forecasts. How do you prepare for that? How do emergency managers plan when the forecast could be anything from spring weather to life-threatening cold? The polar vortex disruption is creating what atmospheric scientists call teleconnections, where weather in one location dramatically affects conditions thousands of miles away. But these teleconnections are behaving in ways that contradict everything we know. Areas that should be warming are cooling. Regions that should be getting snow are seeing severe thunderstorms. It's as if someone rewired the entire atmospheric system. This year, the Northern Hemisphere version is behaving like a machine pushed past its safe operating limits. The core temperatures in the stratosphere are bottoming out unusually fast. The wind speeds along its rim are approaching rarely seen values for January. On meteorological maps, the vortex looks like a tight, focused bullseye of cold instead of the looser, stretched-out ring scientists often expect midwinter. What's particularly concerning is the speed of these changes. Atmospheric transitions usually happen over days or weeks, giving us time to adjust forecasts and prepare. This polar vortex is shifting behavior in hours. Weather services are having to issue corrections to their corrections, creating a cascade of confusion that's unprecedented in modern meteorology. Let me give you specific examples of how this is manifesting across the country. In Texas last week, Amarillo recorded its highest January temperature ever at 84 degrees. 12 hours later, it was 7 degrees with blizzard conditions. That's not just unusual, it's thermodynamically shocking. The amount of energy required to create that kind of temperature swing that quickly is almost incomprehensible. Meanwhile, International Falls, Minnesota, traditionally the icebox of the nation, hit 43 degrees above zero in January, while Miami dropped to 38 degrees on the same day. When the coldest city in America is warmer than Miami, we've entered the twilight zone of meteorology. The jet stream, that river of air that guides our weather systems, is behaving like a snake having a seizure. Instead of flowing in relatively predictable waves, it's creating loops and whirls that have never been observed before. This week, the polar vortex, PV, is predicted to be elongated in shape from the Urals to eastern North America, with the PV center near Svalbard, with relatively cold temperatures focused from the Urals to eastern North America, and with high pressure centered near Alaska, and relatively warm temperatures across Europe and Alaska in the polar stratosphere. The elongated shape and appearance signals a stretched PV that favors relatively cold in Asia and North America, east of the Rockies. But here's what's truly unprecedented. The polar vortex is exhibiting what scientists are calling quantum behavior. It's appearing to be in multiple states simultaneously. Some atmospheric levels show it strong and circular, others show it completely shattered. It's as if we're looking at parallel universes of weather existing in the same space. Now we've reached minute 15, and I need to reveal the most disturbing discovery about this polar vortex behavior. According to fundamental atmospheric physics, what we're observing should create a feedback loop that destroys itself within 48 hours. The temperature gradients are too extreme, the pressure differences too vast. The atmosphere should be working to equalize these differences rapidly, but it's not happening. Day after day, these impossible conditions persist and even intensify. It's as if the normal laws of thermodynamics have been suspended in the stratosphere. Some scientists are privately discussing whether we're witnessing a fundamental shift in how Earth's atmosphere operates, a new regime of behavior that our models never anticipated because it was thought to be physically impossible. The implications for weather prediction are catastrophic. If the atmosphere can behave in ways that violate our theoretical understanding, then every forecast becomes a guess. Every model becomes unreliable. We're essentially back to the pre-satellite era of meteorology, except now we can see what's happening. We just can't explain or predict it. This looming polar vortex disruption is more than just a weather geek headline. It's a snapshot of a climate system under tension. The Arctic is warming faster than the rest of the planet. Sea ice is thinning. And the boundaries between normal winter and exceptional event feel blurrier each year. A near-record stratospheric warming in January fits right into that uneasy story. For those over 40 who remember the certainty of weather patterns from decades past, this new reality is particularly jarring. Winter used to follow rules. Cold air stayed north, warm air stayed south, and storms move predictably from west to east. Those days are gone, replaced by a chaotic system that seems to delight in defying expectations. The practical implications for Americans are severe. How do you plan a trip when the forecast could be wrong by 50 degrees? How do farmers decide what to plant when seasonal patterns have become meaningless? How do utilities prepare for energy demand when they can't predict whether they'll need cooling or heating? Insurance companies are in panic mode. Their entire business model depends on predictable risk assessment. When weather becomes fundamentally unpredictable, how do you price policies? Some major insurers are already discussing withdrawal from weather-sensitive markets entirely. Emergency managers are being forced to prepare for everything simultaneously. The old playbook of prepare for the most likely scenario doesn't work when every scenario is equally likely. Cities are having to stockpile both snow removal equipment and air conditioners, prepared for either extreme at a moment's notice. The energy sector is particularly vulnerable. Power grids are designed for predictable seasonal patterns. When you might need maximum cooling capacity in January or heating capacity in July, the entire system becomes stressed beyond its design parameters. Rolling blackouts could become the norm as utilities struggle to match supply with wildly swinging demand. Agriculture faces an existential crisis. Crop selection depends on predictable seasonal patterns. When winter might last 2 months or 6 months, when the last frost could come in February or May, traditional farming becomes gambling. Food security, already strained by various global factors, faces a new threat from atmospheric chaos. But perhaps the most troubling aspect is what this means for climate science itself. If the atmosphere can exhibit behaviors we thought impossible, what else have we gotten wrong? Are there other tipping points and feedback loops we haven't discovered? Are we closer to irreversible changes than we realized? Is this anomaly caused by climate change? Scientists are still debating the exact mechanisms, but many studies suggest that rapid Arctic warming and changing snow and sea ice patterns can disturb the polar vortex. Climate change doesn't create the vortex. It changes the odds and intensity of its weird behavior. The scientific community is divided. Some researchers argue we're seeing a temporary anomaly that will self-correct. Others believe we've crossed a threshold into a new atmospheric regime. The heated debates at recent conferences have been unprecedented, with normally collegial scientists engaging in fierce arguments about fundamental atmospheric physics. Meanwhile, artificial intelligence weather models, touted as the future of forecasting, are performing even worse than traditional models. They're trained on historical data, and when the atmosphere behaves in ways that have never occurred before, AI has no framework for prediction. We've discovered that machine learning is only as good as the patterns it's learned, and new patterns leave it helpless. What can individuals do in the face of this uncertainty? First, abandon any assumption that weather will follow predictable patterns. Build flexibility into all plans. Prepare for extremes in both directions. If you're planning outdoor events, have contingencies for both blizzards and heat waves, regardless of the season. Second, invest in adaptability rather than prediction. Instead of trying to guess what weather is coming, prepare to handle whatever arrives. This means homes equipped for temperature extremes, vehicles ready for any condition, and emergency supplies that cover all scenarios. Third, pay attention to very short-term forecasts only. While seasonal and weekly forecasts have become nearly worthless, meteorologists can still predict weather reasonably well about 24 or 48 hours out. Make decisions based on these short windows rather than extended outlooks. Communities need to fundamentally restructure their approach to weather preparedness. Instead of seasonal planning, continuous readiness becomes essential. Emergency services need to be equipped for any scenario year-round. Infrastructure must be hardened against extremes in all directions. The psychological impact of this uncertainty shouldn't be underestimated. Humans are pattern-seeking creatures. We find comfort in predictability. When the weather becomes fundamentally chaotic, it creates an underlying anxiety that affects mental health. Support systems need to acknowledge and address this new source of stress. For businesses, scenario planning becomes crucial. Instead of single forecasts, multiple contingencies must be developed. Supply chains need buffer capacity for weather disruptions. Just-in-time inventory systems, already strained by recent events, may need complete overhaul to handle atmospheric unpredictability. The insurance and financial sectors are scrambling to develop new models. Traditional actuarial science depends on historical patterns. When history becomes irrelevant, new frameworks are needed. Expect significant changes in how weather risk is priced and managed. Educational systems need updating too. Meteorology textbooks are becoming obsolete in real time. Students learning atmospheric science are studying theories that no longer match observations. The field needs revolutionary thinkers willing to abandon old assumptions and develop new frameworks. International cooperation becomes more critical than ever. Atmospheric chaos doesn't respect borders. Countries need to share data and observations in real time, abandoning competitive advantages for collective survival. The atmosphere is sending us a message. We're all in this together. The role of citizen scientists grows in importance. With professional models failing, ground truth observations from millions of individuals become invaluable. Your local weather observations, shared responsibly, contribute to understanding this new atmospheric regime. Looking ahead, we face two possibilities. Either this is a temporary aberration and normal patterns will reassert themselves, or we've entered a new era of atmospheric behavior that requires completely reimagining how we understand and predict weather. The evidence increasingly points to the latter. What's certain is that the comfortable predictability of weather patterns our civilization was built on is gone. We're entering an age where atmospheric chaos is the norm, where yesterday's impossibility becomes tomorrow's reality. Adaptation, flexibility, and resilience become survival traits. The stratosphere is teaching us humility. Despite our satellites, supercomputers, and scientific knowledge, the atmosphere still holds secrets that can humble our greatest minds. Perhaps that's the ultimate lesson, that nature always reserves the right to surprise us. Drop your location in the comments and share what impossible weather you've witnessed in your area. Are you seeing summer temperatures in winter? Winter, storms in summer? Help us crowdsource understanding of this atmospheric mystery. Your observations matter now more than ever. Share this video with everyone you know because traditional weather information sources are failing us. When the experts admit they don't understand what's happening, community knowledge becomes critical. Together we might piece together patterns that individual scientists miss. Remember, we're all living through a historic moment in atmospheric science. The textbooks being written about this period will mark it as when everything changed. Whether that change leads to chaos or new understanding depends on how we respond to the challenge. Stay flexible, stay prepared, and above all, stay humble before the awesome and mysterious power of Earth's atmosphere. Because right now, it's clear that despite all our technology and knowledge, we still have much to learn about the air above our heads. The storm that's coming isn't just another weather event. It's a reminder that nature still holds cards we haven't seen, still plays by rules we don't understand, and that reality should both terrify and inspire us to new levels of observation, preparation, and respect for the atmospheric forces that shape our world. Until scientists can explain what's happening up there, we're all weather pioneers, exploring an atmospheric frontier that defies our maps and models. Welcome to the new age of weather, unpredictable, inexplicable, and absolutely unprecedented.